We're up. Let's go.
Awesome. Cool. Well, welcome everybody to episode 52 of Indexer Office Hours. Today is the 15th of March. If anyone is new to Indexer Office Hours, we love participation. You can do so by requesting to join the voice chat or by text inside the stage chat channel in Discord. And just a reminder that this session is recorded and will be distributed via public channels like YouTube. Our agenda should be in the stage chat channel. If it's not, actually dump it in there now, so you can follow along there. And today's a big day. Today's episode, number 52, marks over a year of Indexer Office Hours. It's been an absolute pleasure to share this space with you all. And I know that for many, it's been not only an invaluable way to stay up to date with indexing, but also a place for community bonding and an opportunity to get to know the humans behind the avatars. So to mark this special occasion for everyone here, you will be able to claim a special 50-second Indexer Office Hours POAP. For anyone that isn't familiar, POAPs are collectible NFTs that commemorate special events. To claim your POAP, you'll need to download the POAP mobile app and then use a secret word to claim your NFT. Listen out for the secret word later in this session. And be aware that you can only claim on mobile and that claims will close roughly 10 minutes after the end of Indexer Office Hours. Further, to commemorate this special edition, we asked indexers to share some of their favorite moments in Indexer Office Hours over the last year. And over the course of today's episode, we'll share these responses with you. Personally, IOH has been really pivotal in my own journey in the graphs ecosystem. And it was really the easygoing nature of discussions that led me to begin contributing, and also gave me the confidence to share my opinions more openly. Other special moments, so Payne from 𝗨𝘀𝗀𝗳𝘂𝗹 said, "I still remember the first Indexer Office Hours session that we had, how we were all there, perhaps a bit nervous while doing the introductions. Damn, it feels like it was just a couple of weeks ago, not a year." That definitely resonates for me too. Over to Anna, who will tell us about episode 52 of GRTIQ.
Hi, Chris. Thanks for handing it over to me. And hello, everyone. So in the last week, we have had a new episode of GRTIQ. This is Craig Burrell from Reciprocal Ventures. Craig gives us an insight into the kind of Web3 companies Reciprocal is investing in, their recent investment in Ceramic to achieve more flexible data streams and easier file and content sharing, how that will change the space, the Web3 video sharing space, as well as some advice for entrepreneurs regarding patience and curiosity. Very interesting episode. Let's jump into our regular segment, Repo Watch. So in terms of our major blockchain clients, we haven't had any new releases from yet. The last release has been version 1.10.16. Then for Aragon, no new releases. Last release 2020-02-04 beta. For Open Ethereum, again, no new releases. Last release version 3.3.4. And for Streaming Fast Get, we have had a new release. We have had Polygon version 0.2.14, and it's a temp spam hot fixed DM. And before I move over to Graphs Stack, has anyone used the Streaming Fast Get release and have had any insights they want to share with us? If not, I will move on to GraphStack. For the GraphStack, we have had a new release of GraphNode, so version 0.25.2. This is the last version 0.25 before 0.26. And this contains a bug fix of blocks being skipped from processing when a deterministic error happens and the index node gets restarted. So this closes issue 3236. And it also contains other automatic retries for non-deterministic errors. And this closes issues 2945. We also have had a new pull request submitted by Matteo, which deals with checking chain continuity with subgraph block pointer if the subgraph never processes any blocks. So this change temporarily solves the firehose filters problems when deploying a fresh new firehose subgraph with filters. And it will also speed up starting subgraphs on other chains since we can completely skip the continuity check. To me, this is a really big PR, so I'm looking forward to seeing it. And then we also have pull request 3358 submitted by Yanis. Thank you for submitting. This adds a public proof of indexing resolver so that users can retrieve comparable POIs that can be shared in public. However, those POIs cannot be used to get rewards without doing the work. So this to me looks like we're moving to have the private POI that indexers will be using to get their rewards, and then this is a public proof of indexing. Then moving on into indexer service and agent, we haven't had a new release. Last release has been version 0.19.0, which was a pre-release. And we know that a few of you have already tested that. And on indexer service and agent, we have a new pull request 389. Thank you, Hope, for submitting. This adds a safety check before opening an allocation so that if the subgraph deployment wasn't closed with the 0 POI, the agent will skip allocating it. Hope has been on a roll with another new PR that she has submitted, which is 385. It's indexer agent improvement on redeeming receipts for the voucher to avoid hitting the gateway max body size. Again, thank you, Hope, for submitting all of this. Back to the community. Has anyone had anything to comment regarding the new GraphNode version, or any more experiences with version 0.19.0 of indexer agent?
Yeah, so we're running the 0.19.0 pre-release in production, and everything has gone very well so far. So I'd encourage other indexers to test it too. The one gotcha that I observed was when you start 0.19.0 for the first time, it will migrate any existing indexing rules into the new format. And part of that migration, at least in the current pre-release, means that the base 58 representation of subgraph hashes, so those QM hashes, get converted into bytes 32 representations, which is that 0x blah 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 that we're used to. This is a little bit confusing at first, and at least one gotcha I observed was it's possible to create indexing rules, or multiple indexing rules for the same subgraph by specifying both the byte 32 representation and the base 58 representation. So this is a known issue. I believe there's already a PR in the works to fix it, and is really we're down to like the very last edge cases on that before we see a 0.19.1 release soon.
Chris, I have a question though. Isn't it a bad idea to remove or deprecate parallel allocations entirely? Like, I know there's a PR coming from Ariel where it enables allocations with zero GRT, so you can stay allocated to like all the network subgraphs and basically give up on indexing your words, yet still get query fees, yada yada. So let's say you also run that in parallel with normal allocations, then you can still not having to like you can still stay allocated with your zero GRT allocation, and then also allocate if it's good for indexing your words towards those subgraphs, and pull out without like whenever it becomes not optimized, like whenever your allocation strategy is not optimized anymore, you can pull out without like stopping to index that subgraph or stopping to serve queries for the subgraph entirely. Does it make any sense to you?
I think I do understand the question. My interpretation was that parallel allocations would allow an indexer to both kind of create a backstop allocation in parallel with a non-backstop allocation.
Yeah, okay.
Is that what you were getting at?
Yeah, so this is what I was getting to. Like, I want this functionality to be enabled. Like, I want regular allocations to be working alongside backstop allocations.
Mm-hmm. Yeah, I can recognize that deprecating parallel allocations would prevent that. I think the recommendation on backstop indexing is that you set up a separate indexer for that kind of thing. Obviously, parallel allocations were originally put into the protocol to enable query payment scaling in the kind of very early iterations of the state channels design. But newer iterations remove that limitation. So there's really no need to scale the number of allocations to scale the number of inbound query payments supported. So that was the original reason, and obviously they've now been deprecated. And the deprecation has largely just been to remove complexity, both in the indexer software, but also just cognitive complexity for the indexer. Because outside of the case that you just highlighted, for more typical indexing activity, it's just more cost effective through and through to reallocate rather than trying to manage multiple allocations.
I have an idea actually how we can go around that issue. I think the solution is very simple. You can put the agent not to look for zero GRT allocations, and then you open those allocations manually through Etherscan for the backstop allocations, basically. And thus, the agent won't reconcile the zero allocated GRT, blah, 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 and you can allocate normally outside of the backstop allocations.
Yeah, that's an interesting one. I think we should, move discussion on that to later in the session, or do that offline.
Yep, there's also something
also-
that I will be mentioning regarding zero GRT allocations, which, by the way, aren't possible right now. But yeah, I'll be adding a little bit more information in Protocol Watch about that.
Yeah, speaking of index agents and service 19, version 19, alongside we've been running it alongside with the graph node version 25.2, and like everything seems to be normal to me, but the only issue that I've seen is that subgraphs that failed cannot be closed automatically through neither, like the agent isn't able to compile a POI for that. Is it normal behavior? Was that thing ever working? Because I never tested it out.
Yeah, I think that behavior has been long-standing behavior. One of the items in the ongoing points of interest section, which we'll cover later, is, I think it's issue 3059, if I remember correctly. On GraphNode, which is tracking instances of subgraph failures where deterministic failures are being incorrectly categorized as non-deterministic. I believe that if a subgraph has failed deterministically, then graph node and by extension indexer agent should be capable of producing a POI for that subgraph. But we have had a number of instances where that categorization is not correct. And in those instances, graph node will not generate a POI for the subgraph because it doesn't believe the failure was deterministic.
Do you know if mstable and enzyme have failed deterministically or not? Because they can't be closed right now, so at least in our testing.
Okay. Yeah, let's debug that offline. I
Okay,
don't know
cool.
about those two offhand.
I already told Ford and sent logs to him, so I think we're good.
Yes, Ford will save us. He always does.
Awesome. Thank you for the comments and the discussion. Before I hand over back to Chris, I'm going to share with you guys my special moment regarding indexer office hours. Mine has been, so although I haven't been around the community as long as you guys, for me, some moments that stood up were a few sessions at the end of 2021 when we were talking about how to incentivize indexing of public goods graphs and how to discourage stuff like signal manipulation for rewards extraction. So both of those, to me, showed that we're working to build something really sustainable that cares about all of its participants. And with that, I will hand over to you, Chris.
Thanks, Anna. Cohen, I saw your light flash. Do you want to add something?
Sorry, I was just hammering the keyboard.
How dare you? No worries. Okay, thank you, Anna. And yeah, I guess I'll also add that Vincent Taglia, who's one of our indexers, he in his special moment he referenced Anna's and he said, I have to jump on your favorite moment here. I really liked how we came together and shared our different points of view on this topic. It was one of the first topics that I felt comfortable weighing in on with my level of knowledge on the protocol at the time, learning more ever since and loving every second of it. Thank you to Vincent for sharing that. Okay, next up we have Protocol Watch. Over to you, Juan.
Hey guys, so yeah, there's fortunately this week we have a ton of stuff to cover on Protocol Watch. I'll try to be brief because most of the juicy content you will be able to see it in the forums, and if we've covered everything here, it would take us more than an hour. But yeah, so going with the contract side of things first, and this is a reference to what Payne was saying. There's a new PR on the contracts to allow for 0 GRT allocations. It wasn't possible before. There was actually a requirement for all allocations to be over 0 GRT. The idea behind this is coupled with the discussion for sale allocations, so being able to open 0 GRT allocations for the backstop indexers and make them, let's say, immune to the stale allocation incentivization closing stuff. So basically, so those two different things don't fight against each other. So yeah, there's a ton of discussion with that topic, which we'll cover a little bit afterwards. But yeah, it would basically be possible after this PR to do what you wanted to do, Payne. I'm not entirely sure if the workaround that you found to have both allocations open would work, but at least you would be able to open a 0 GRT allocation once this is merged, if this is merged too, because it does need to have consensus behind it. Going over to the subgraphs, there's no new updates. The last update was regarding the subgraph NFT transfer. So yeah. And then we get to the juicy bits, which are governance and research. Going into governance forum discussions, there's a really good news regarding Radical. in the 001 GIP thread, Brandon updated us that we have a bunch of stuff regarding Radical, a bunch of updates regarding Radical. There's a new workflow that we can use. The major thing, at least for me, is that we can now look at the GIPs in Radical directly from our web browsers, which is, at least for me, a game changer. It was one of my main issues with Radical before. It was, at least for me, it was hard to use, not always very compatible. It seems that the CLI is also much improved right now. So if you wanted to go that route, you could go that route too, but you can use the web browser if you're lazy or anything to be able to view all the GIPs and all the updates there. So yeah, that's extremely good news. Going into the next topic, the stale allocations. There's a lot of debate going around the stale allocation incentives, whether it should be incentivized or not. So yeah, but on the middle of those debates, there's also the PR from Ariel to like be able to close any indexer allocation over 28 days, even if you're not a delegator, which is one of the let's say one of the issues that you have right now. You need to delegate, even if it's super easy to work around it. You need to send more transactions, and it's a waste of time. So removing that and also allowing for zero allocations would be great for that topic. Going over into our next topic, we have data edge. There was a small update. Ariel uploaded a reference implementation for the data edge contract. And next we have the feature support matrix for the network. The feature support matrix for the network basically so that we can have pretty deep knowledge on what features are actually usable in the network and which ones are not, and also to allow determinism on which which subgraphs can actually be indexed and closed with index and rewards and stuff. So it's coupled with a lot of other topics like the query versioning one. It's tangled with all of those. It's a really interesting one. It's a really long one too. So I would love if you guys could actually go look it up in the forums. Yeah. Then we have, I don't know if any of you guys want to add a little bit about that. I see Brandon and Sakat here, so maybe you want to add a little bit about that.
Yeah, I don't have anything to add there per se. Just that between that, the query versioning GIP that Zach has been working on, and a few other kind of changes that have been discussed, getting the arbitration charter over the finish line and like actually ratified by the Graph Council is becoming a priority again. The GIPs on Radical that you were referencing, that's actually partly enabled by a new feature on Radical called Radical Orgs, where actually we have a Gnosis multisig representing the current set of GIP editors, and that multisig can anchor a commit from a Git repo on chain. And so that's actually like when you view the GIPs now in Radical, you can see the anchored commit. You can also see other commits and branches that have been gossiped over the peer-to-peer network. But we're planning on doing something similar for the Graph Council, where the Graph Council in the future will be able to ratify versions of GraphNode. And also we would like the council to ratify the arbitration charter. And so that GraphNode version plus the feature support matrix, that'll kind of become a canonical source of truth for what is the specified behavior for subgraph API and indexing in the network.
Yeah, but it's really amazing to see all the progress that's been done, and it's all been done pretty one after the other. So that's also truly amazing. Cool. Moving forward, we have the forum research section. This one's also super bloated, so I'll try to make it brief. There's proposal / GIP for principal protected bonding curves. This one's really close to me because I'm working on the actual implementation. Principal protected bonding curves are kind of like one of the first steps that we want to take to let's say, improve curation, kind of like curation v2 or v1 dot something. But yeah, it's the first stepping stone that all other improvements should rely upon. It's a super extensive text that Brandon thankfully had the luxury to write. It's super amazing, super interesting, super useful, but it's way too long to cover in IOH. It's just the small summary is that it's a new form of bonding curves that will replace the underlying curation bonding curves to make it more predictable and less risky to go into. Moving forward, we have 𝗨𝗂𝗂𝗧𝗂𝗂. There was a small update from Ariel regarding the possible gas optimizations that batching with multi-call would bring to indexers, like if 𝗨𝗂𝗂𝗧𝗂𝗂 was merged. So yeah, there are some figures there. They seem pretty optimistic, so they are super cool. Moving forward, we have a new topic called grafting in the network. It's gonna be a discussion in the open discussion section, but to give you a brief summary, it's a small discussion on whether the grafting feature could be added to the network and made deterministic. Grafting is deterministic anyways, but there are a few caveats when you have grafted subgraphs, especially with the dependency tree of the subgraph. But yeah, we'll have an open discussion section for it. So yeah. Then there's some more updates on the recent POI discussion, whether having more recent POIs for the allocation clauses. I think Brandon added a comment regarding a few other research branches that we are following that could potentially have some impact there. Particularly, there's a few PRs from Ariel regarding adding a POI requirement for opening an allocation, which could impact this. There's also the block oracle that could also impact the freshness of the block used for POI clauses and a bunch of other stuff. So if you have anything to add to the discussion, it would be super amazing to add it there. And there's also a small update on one really old topic regarding flattening the bonding curves on curation. There has been many other ways to improve curation that we've been looking at, particularly principal protected bonding curves that have this behavior that would allow us to replace the flattening of the bonding curve, which has a lot of downsides that we've been discussing for a long time. So yeah, we are basically pursuing other ways to improve curation rather than flattening the bonding curves. Does anyone have anything to add or any questions regarding everything that we've been covering here? That I'll take that as a no, and basically that will be all for Protocol Watch. But before I hand back over to Chris, I want to add my little special moment on IOH. It was really hard to pick a favorite moment. There's been way too many moments that are really, really nice. But whenever I try to think of it, the first thing that comes to mind is the first time that I got to co-host IOH with Anna and Chris. I'm not probably one of the most experienced persons like hosting stuff, so I was always super nervous doing this, but it was super amazing, all the support that we've been getting and all the love that we've been getting, so it made me feel very, very special. I'm privileged to be here, so yeah, thanks everyone for that. And back to you, Chris.
Thank you, Juan. And it's a real pleasure to have you with us. So you guys know the drill, more special moments. Jim from Waves 5 said that Indexer Office Hours number 22 was Curator launch week and had some great memes. And Steak Machine, Lex Prime, and Jim himself have made some great memes. We'll get those shared in the stage chat. Cohen from Mind, Heart, Soul said, there's been a few times I got specifically asked questions about non-mainnet, non-Ethereum indexing, and I've enjoyed sharing that, perhaps niche experience with the wider community. Yeah, thanks, Cohen. I know that you're often looked to as an expert on non-Ethereum indexing, and yeah, please keep sharing your insights with us. Finally, Derek from Data Nexus said, something that rings for me, although it won't really mean a whole lot to others, is listening in while I'm in the office and being like, okay, I'm going to go take a smoke break because I want to say something. And he also says, I wonder if we could count up the number of "Where's Ford?" exclamations. And sadly, Ford is not with us today.
Hence the question.
Yeah. And these are the important questions, and I'm glad we're covering them here. So next up, we're on to our ongoing points of interest, where we keep track of ongoing discussions or issues that are relevant to the community. This is going to look pretty familiar, folks. First of all, we would very much like to help the core devs with graph node determinism. And part of determinism, of course, is your system locale and also your Postgres locale. So I've dropped a link to a form in the stage chat. If you're an indexer, please take just 1 minute. The form will explain. You just need to run one SQL command to get out your current locale and submit it in the form. This really helps us to ensure that there's full determinism through the stack. So if you could do that, if you haven't already, that would be fantastic. Otherwise, just another shout out for the issue number 3059 on GraphNode, which tracks variants of deterministic errors. This is subgraph failure deterministic errors that are incorrectly categorized as non-deterministic. If you see instances of this, please report the details in the linked issue. This helps us fix categorization and will also get us to a point where we can get rid of the manual closure workflow and just make the UX for indexers better. So that's it for ongoing points of interest. So we got a few more special moments to share. Vince from Notify said, the most memorable for me would absolutely be the first Indexer office hours I attended, when I had thought about branching into indexing and I was very new to the graph. Listening to Jim, Payne, Chris, and Cohen speak or chew on some ideas about things within the protocol had me thinking I'd mistakenly joined a NASA JPL conference. Thanks for sharing, Vince. And you'd be surprised the number of people in the ecosystem with, an aerospace kind of mad space people background is a lot more than you would expect. Oliver from the Graph Foundation said, I would say that the Index Africa fireside chat left a lasting impression with me. It really drove home the point of a larger mission that Web3 pursues, which is to create access and opportunities for everybody around the world, especially those who don't currently have those means. Thank you, Oliver. I think that one probably resonates with all of us. Next, we are very lucky to be joined by Stefan from Streaming Fast, who will be chatting with us about improvements to the Firehose. Welcome, Stefan, and thank you for sharing your time and insights with us today.
Thanks, Chris. Happy to be here.
Awesome. So I guess to kick it off, what brought you to work on blockchain data problems? How did you get here?
That's a funny story. I've worked a lot with 𝗨𝘀𝗳𝗏𝗀𝗀, the CTO of Streaming Fast, in different ventures and things. And someday he just asked me at some point, hey, we have these, database problems, and it's, we have this log that keeps increasing, and we have these problems managing this data, and some of it is immutable. So I jumped in, and then next day I was working on blockchain.
Alex has that effect on people, doesn't he?
Yeah, he knows how to get you how to get you excited about the tech, and then slowly, gradually make you jump in the whole shebang, the whole space. So yeah, I really learned a lot in these last years working at Streaming Fast with him.
That's awesome. And it sounds like, data was something that you were, working on quite deeply beforehand. So what led you into data before crypto and blockchains?
That's a good question. It brings on lots of interesting problems. I have a background of more ops side than dev first. So what I've seen in the last 15 years is the cloud approach, enabling parallelization of problem solving via parallel instances. I've seen this applied to a lot of things, and I've seen it applied to data where you could where you would have like a bunch of data to process. You would just split it in different parts, and you could code the whole infrastructure to you could the infrastructure could become a software program that would solve the problem. So really bridged the gap for me from doing strictly ops and then infrastructure as code, then to jumping into real software engineering. So yeah, it's a good problem for that.
Yeah, that makes sense, and couldn't agree more. Thanks for sharing. So for those who aren't already familiar, what is the fire hose?
All right, so the fire hose is a Streaming Fast's approach to solving the problem of streaming a very large data set that is ordered. Okay, in particular, well, in this case, blocks. So it's like a time series database, but it's actually a block series database, something like this. So your how the fire hose works is you actually instrument the node. It could be a Geth node, it can be a Solana node, some Near, we've done it with EOS. So we've instrumented a bunch of those, and we have some colleagues over at Figment doing it on other chains. So you instrument the node to quickly push the data out in a kind of a flat file layer, a flat pattern where every block is just a set of bytes with all the data. It can include state changes, previous state, next state, and all of this. So you never have to do a query on a stateful node. You just export on every block all the data that you need. So this is the first principle. So by instrumenting the node and pushing everything out into a stream of bytes and saving this to disk, it gives you the building block, well, pun intended, of course, the building blocks of building a data processing layer that can take any chunk of data from any block and process it, transform, and basically do ETL on it. So yeah, the fire hose is all of this. First, the extraction of the data from the database using from the blockchain node using the what we call the DeepMind plugin. We might change the name of that. There's some discussion with Figment, but this extraction layer gives you the flat files that you can just push to a distributed storage, and then you can do all the processing, the transform part. In parallel with different Firehose server instances, and then you use it. In our case, we use it to load the graph node.
Yeah, thanks for sharing. And the fire hose. I guess So you spoke a little bit about kind of, the like technical architecture of the fire hose, but maybe you could share, like, why does that pattern, and you kind of alluded to this in a previous answer, but why does this pattern of extracting data, why is that particularly well suited to the workload that is indexing blockchain data?
Well, we do like to work with flat files a lot, and this is what the Firehose gives us at the first level. The first thing we do is we transform something that is stateful, something that changes, something that you have to query against, that you have to keep like a lot of things in RAM, and you need like big instances to process some requests and to serve, and this is harder to scale from our experience. As soon as we can get everything in a flat file on a distributed, network-based storage like Amazon S3 or whatever Ceph-based S3 implementation, as soon as you have it there, you can scale infinitely. You can have any bunch of workers doing data on this, and like in a data warehouse, big data pattern. With the blockchain, everything past a couple of hundred blocks is immutable. So, putting this in a low cost, high parallelization storage format, it's really well suited for that. It will never change. You don't need like to manage. You don't need this running in a database. At least not in the first layer. So yeah, extracting that as fast as possible out of the node. Also, it protects you against all the difficulty of modifying the storage layer. If you had to change the indexing, you have to change this. You can always start back from those files and reprocess to where you want to go. So the immutable nature of this data really makes it a good pattern to just try to extract it to file, and then we can share those files. We've sent some of those block extracted files from that are compatible with the Firehose. We've sent those to some of our friends to play with, some of you guys indexers. Because it's so easy to just send it, and you can use it even if the version of the node changes. It's still, those data files are still compatible.
Yeah, that makes a lot of sense, and maybe I could share one way of thinking about it that I think is really helpful. And I guess the seed of this, I wish I could correctly attribute, but I honestly can't remember where I heard this, but it's definitely not an original thought. I want to say maybe Derek, Data Nexus, is where I heard this, but kind of like coming back to why something like the graph actually exists. If we imagine that a blockchain is kind of like a Walmart store, and that Walmart store gets deliveries, trucks come along and deliver new merchandise every hour. The way the blockchain works, the way it lays out its data, is essentially that each truckload kind of arrives and is just dumped on the floor. Right? No one goes through that pile and sorts that pile into, shampoo and, I guess in the case of Walmart, semi-automatic weapons and food and whatever else. It's kind of you just have these piles of stuff. And so I guess when we're getting data out of the blockchain via RPC, as you said, there's this stateful process that we actually have to go and ask to say, GRTIQ just shared that it was Kyle. I want to say his name right. Roja or Rojas? I butchered that. I'm sorry. But yeah, thank you, Kyle. It's such a good
Rojas.
Thanks, Brandon.
Rojas.
So it sounds like, even though the data is like laid out is kind of just blocks or piles of unsorted stuff, it doesn't really make a lot of sense that to scan over those piles, right, to like, look at like how many of this particular brand of shampoo that we have, rather than just kind of, looking through all the piles and sending, 10 people to do it all in parallel. You kind of have to ask this node that intermediates everything. So it sounds like, in some sense, what the Firehose does is like replicate that idea, right? These like just one flat file per block or pile of stuff, and really like disintermediating, reading that data from requiring this active stateful process to do so. Is that fair to say?
Yeah, that's a pretty cool analogy.
Yeah, thanks again, Kyle. Awesome. So I guess maybe the other thing to say about the indexing code is, as you said, because this is time series data and it's for the most part immutable. When you're indexing over it, you almost always start from the beginning and scan through all the history, from the beginning to the current state. And every time you're indexing, you're doing that same pattern over and over again, scanning from the beginning of the history to the present.
Yes, if you're, this really depends what kind of data you need. If you need to know what are all the transfers from one address to another, or you want to know, you want to count the actions per block for a given contract. In this case, you don't need to restart from the beginning because it's all event-based data that you're extracting. You don't need anything to be stateful to start at block 12 million. You just start at this block and you start processing the data and you output it, right? So basically the Firehose currently does not do state aggregation, but it provides you with a quick way to parse this data in parallel and send it to your system that will look at the data it wants and then do the aggregation. So it's like like I said, it's a building block. You will have to start over from the beginning, like in a graph node when you want to reindex a subgraph, and you need to build out all these states starting from block 12 million up to the head. The Firehose works well in this linear way. But depending on what kind of data you need, you might not have to go back at the beginning. I don't know if I'm making myself clear or just making it more confusing.
Right. No, I'm following, I think. And maybe kind of switching gears slightly, I can definitely see how, the Firehose disintermediating access to that data, particularly for indexing workloads where we can, scan over that history in a highly kind of parallelized way and leverage really cheap storage. It seems like a absolutely incredible, shift in architecture and really great for the indexing workload. But would you say that there are any cases where the existing RPC-based indexing pattern is better than Firehose-based indexing? Are there some subgraphs or workloads that Firehose isn't quite there yet on?
Yeah, I'm glad you asked. So the cases where it will excel, if you have something that is, you want to index something that is really dense. For instance, if there are actions of interest in every single block on the Ethereum mainnet, and you just want to, to get the data, you run your local low-cost analysis of this data to look what matches. Like, okay, this transaction matches what I want, or this log event matches what I want, or this call is to the right contract with the right method, the right signature. All of this you can do locally if you have the data of the block. I will just stream to you every block, 1 megabyte per block. You go through it, you take what you want, and you get to the next block. And I can, the Firehose can send you those blocks really quickly. However, if you are indexing like a subgraph where you have one action happening every 10,000 blocks, in this case, streaming to you every block, well, it does not seem like a good idea, right?
So while it will excel, it will give you a good performance, like a good performance gain if I send you the whole block. If there are like 10 matching events in this block, because the other way around would be for you to do a query against a like a filter, a log filter, try to figure out what transactions are of interest, and then you will do another call for each of those to get the transaction or to get the block or to get the data and try to extract more data from the node, asking for the traces, asking for whatever else you might need. We've seen this in Uniswap kind of subgraphs, where there are so many transactions in any block that you will have like a quadratic loss in performance. The more pairs of swap and stuff, the more contracts you watch. So I don't know if I'm making myself clear on this case. You have this for each block. If you're matching 10 log events, you will have, and you want the whole data with the traces, you will have to, look back and then ask for each of those responses. You have to do the queries against the RPC node and ask for more data.
Right. So you need an answer before you can ask the next question. Is that?
Yeah. Well, most of them can be done in parallel, but you're still going to do. I don't know. We've seen stuff where pancake swap subgraph where we had 200 queries being made on a single block because of the logic of trying to fetch all the information based on the result of a query or on what would match, or you would do like a queries like a list of contracts, and the load, that the burden that you're putting on the geth node to answer you, or to Infura or whatever provider you're using, you're putting the load on this side to do some logic on a stateful set of data, and this geth node is already crumbling under the workload of processing block, validating, doing all the signature check, and then keeping this state.
Right.
So definitely in this case, for a very dense subgraph where every block is of interest, the Firehose will allow you to have the burden on the client side and with all the data right away. So you remove the latency for every call for a bit of data.
That makes sense.
Yeah.
It sounds like there are really two things at play there. One is, because accessing the data is completely decoupled from the stateful node process, consuming it creates no additional load on the node.
Yes.
So yeah, that's very, particularly for high throughput chains that have very high consensus and execution loads, that's a big deal.
But it doesn't stop there. I've told you like what is the advantage where it shines, where you have something very dense. But when you have something very sparse, you need something else. You need some form of indexing. Also, if it's really sparse and you want to reduce the size of the block that you're getting, you need some kind of filtering or transforming inside the block. So we've done this. We've done both of these implementations. They are being added to the graph node client side to consume them. But typically, given a filter of what blocks you want, what calls or what log or signature methods you want, the Firehose can reduce the payload of the block. Just take the transactions that would match, include all the data around, the traces and everything, but only for transactions that match the calls that you want or the logs that you want. So you can get a reduced payload, 1/10 or 1/100th of the size. So this will, we feel this is the right way to solve this, because those blocks can be prepared in parallel, reading from the file and reducing the size of the block in the Firehose before we send it to you. And another thing that's been implemented is
simple indexes for the presence of a call or a method or both. An address of a call or a method of a call, or same thing for the logs. And these tell the firehose ahead of time which blocks will match, which block number will contain these kind of transactions, so we can skip big ranges, like the 10,000, one every 10,000 touches this contract with this call. Well, these indexes that are a new addition can now help the firehose skip all those blocks.
Right. So yeah, let's just walk through that. So without these indices, if I was a sparse subgraph and I'm consuming the firehose stream, I'm probably going to be getting a huge amount of block data and needing to process that block data, right? Filter through it and search for triggers that is just completely not relevant, right?
Yes.
And yeah, so it sounds like, on the one hand, that could be solved by, sending less data to the node and having Firehose just filter out the blocks that are irrelevant. But presumably, if Firehose was doing that on the fly, right, like reading flat files, applying some filter to basically select matching blocks, and then only sending those matching blocks downstream, that would probably create like a huge computational overhead, right, to process all of that data. So how is the introduction of these indices, how does that change that? And can you tell us about how these indices are defined and stored?
Well, we've built a system, a system of what we call transforms. It's in a broad sense, it does filtering or transforming of the payload, and it also informs of the blocks that you might want to skip. So it does a lot of things, and those transform is an array of pretty much anything. There are protobuf defined set of bytes, so you can send those in the query to the Firehose, and they can. There are an infinity of type of transform that you can ask for. So this leaves some room for improvement and adding other kind of indices. Currently, the ones that we've implemented are the ones that match the definition of the subgraph handlers or filters right away. So we've added two type of indices in the Firehose over Ethereum blocks. One for logs, one for calls. So it really matches what the graph node would query. And what they do is they are also flat files, so they can be queried. They can be loaded on at runtime from a Firehose. The Firehose will look at it. It will hash the kind of pattern of method or signature or address, and look at the presence of this hash in the index file. And it's like a key value, really simple key value store. And then what it gets for that given hash, if it exists, is a bitmap that tells it what blocks will in this range, what blocks will contain such calls or such logs. So imagine you have all those block files. One is, from 0 to 100, 100 to 200, 200 to 300. These are all the raw data of the Firehose. You could have another folder right next to it from 0 to 10,000, and these will be the indices for all the calls address and the call methods for blocks 0 to 10,000. So you can just look at this. The Firehose can look at this, read it, look for your queried addresses and methods. If nothing matches, it will skip to the next. It will start at block 10,000 and then look for the next indices to see what is there and what is not. So you can skip large ranges of blocks by doing this. And since some people will ask, yeah, but why not use a database with indices in the database and a Postgres and everything? Well, what we like about our solution is that since it's completely immutable, this file that represents the indices of addresses in a call from 0 to 10,000, well, this is a small file of 20 megabytes or 5 megabytes, depending on the chain. and it's immutable. So we can cache it locally, we can look it up anytime, and it will just work without the burden of running a database that is meant for mutability and runtime modification of the indices and all of this. We don't need this. So we've kept the system simple with flat files at every level.
Oh, flat files, man.
Yes, we do love them.
Stefan, sorry to interrupt. We are a little bit over the top of the hour. So I'm going to go ahead and share the secret POAP claim word, which is IOH52. That's capital letters IOH52. You can claim that inside your mobile POAP app, and you have about 10 minutes to do so. Stefan, this is such a great conversation. I know that a few had to leave because we're at the top of the hour, but I would like to continue for a short amount of time. So, yeah, you kind of explained, that these indices are flat files, that the fire hose can read those flat files to understand whether a given query, a streaming query, matches particular blocks. If the indices indicate that those blocks don't contain matches, then it can skip over reading those blocks completely, and ultimately, downstream. The downstream workload just gets a lot less data, and you're not trading away, computational throughput on the fire hose to do that. Is that a fair description of things?
Yes, that's pretty much it. So if you do query the fire hose with a given filter for calls and everything, you will get two things. You will get two effects on the response. You will get blocks. I don't know. You start at block 1 and you ask for just calls from a WETH address. Call to WETH address. Sorry. You will get block 10,000 and then block 20,000 and something. And in each of those blocks, you will only have the transactions with all the traces and the changes in state and everything that we store in those blocks. But you will only get those transactions that match the WETH contract address. Right. So it will skip all of those. And when you get close to head, then we stop doing the skipping, because you will not get a few hundred blocks per second or per minute. You will get a real time speed. So then we send all the blocks so that you have a cursor to connect back to where you left off. We don't want to leave you hanging without any answer for too long, because then when you reconnect, you would reconnect at a starting block really far in the past. So at some point we may send you blocks that are empty, even if they don't match the query, just so that you can update your last seen head block or progress scenario. If you look at the block, there's nothing in it. There's no transaction trace, only the context, the block ID, the timestamp, and all of those.
That makes sense. And yeah, glad to hear that, because I know that the Firehose and more broadly Streaming Fast's cursoring system and the stream resumption that you can do as a result of that is pretty cutting edge. I'm not aware of any other system that provides the same level of resumption and consistency guarantees. So awesome to hear that applies here too.
I'm glad to hear that. We like it too. We built it to solve something that we saw was an issue. Everywhere on any blockchain, any system, we've seen it an issue everything based on block numbers, and you have to poll again, try to see, did the head change? It's not the right head anymore. I need to do some more polling and then try to figure out what blocks were changed and then look at the block IDs. So you're multiplying the RPC queries just to figure out what's going on with the head. Whereas if you keep the cursor from the Firehose response and you are on a block that eventually get forked out, the Firehose will send you undo signature of here's the block that I've sent you, and the action to take on this is undo. So whatever matched in this block, you can now remove it, and up until you get back to the canonical chain. So yeah, we're really proud of that system.
Yeah, that's a big deal, and certainly goes far beyond any other offering, as I said, certainly that I know of. Final question for you, Stefan. Given that we're well over, so today it sounds like there are at least, for some chains, existing defined indices for log topics or for call signatures. How are those defined today, and how do you see the definition of these indices evolving over time? Do you think that this will always be something that Firehose developers kind of decide on and kind of look at the trade-offs associated with like how valuable an index is, how often the index is actually matching incoming filters versus the size of the index, and like is that does that decision lie with Firehose developers, or do you see, indexers or even subgraph developers playing a role in defining these indices in time?
Well, good question. There are a couple of things going on at Streaming Fast right now around the Firehose and the indexes. Currently, the indexes that we've implemented for Ethereum, and we have some for Near also. They cover a lot of things. They cover most of the requests and how it's been defined in GraphNode and everything. But we thought about the possibility for any indexer to decide, okay, I will add these kind of filters, but then how is it going to be consumed? It has to move kind of in parallel between development of the client side in GraphNode and the development of Firehose. So we said, that could be cool, but we kind of pushed the reasoning a little bit further and thought, well, now we have this big ETL and we're already taking blocks and removing some stuff from it. Could this go further? Could we have some kind of, some higher level filters inside of the Firehose? At some point, we experimented with, adding pre-processed data to the block. For example, if a transaction is related to ERC20 transfer, we could add in the name, the symbol, and the decimals in there. Why not? Everybody, well, not everyone, but any exchange or a lot of contract will be interested in this kind of data, and they always have to kind of do a side query, RPC query, try to figure out, is this an ERC20 contract? What's how many decimals? And this little dance always has to happen. But adding these kind of metadata or kind of parts of a state to the Firehose response, we see a lot of possible avenues for that. We see that this could solve a lot of things. So doing a little bit more of T from an ETL, so a little bit more of transform in the Firehose before we send it to the GraphNode, before we send it, but trying to maybe generate indices dynamically and then use them in another query. We're really deep into exploring all that can come out of this. So I will be really interested into hearing ideas from indexers here, ideas from users, customers, subgraph developers. What kind of additional data could be appended to the Firehose response so that it would make the work inside of the GraphNode easier, so that it would allow more composability before we even load the data in the database. So this is kind of where we're going with that. This is what we're exploring, trying to see what sticks, and we've come to a bit of a aha moment where we've found we can do a lot of more transform than simply filtering the content of the blocks. So it's not just about the indexes, it's about what we can pre-process before we send the data to the final customer, which is the in this case the graph node itself.
Yeah, that's a really kind of fascinating overlap in the sense of leveraging quite a generalized and powerful transform system to generate indices, but also, I mean, I guess like any of these arbitrary transforms could be applied both like on the fly, just with the CPU, or that work could be done and then cached as flat files, right?
Yes, of course, flat files.
Awesome. Well, yeah, I mean that's a really interesting kind of vision for the future, and I can certainly see how those transforms in particular could unlock, I guess just make querying certain types of streaming data a lot more viable today, and being able to put the capability of defining those transforms and therefore those cached indices in the hands of the end user is super powerful. And that actually kind of reminds me of what the graph enabled, by allowing dApp developers to solve their own data problems by writing a subgraph and not having to rely on some centralized entity to make the decision to actually index the data is hugely powerful. And it feels like this is very similar in spirit, putting that capability in the hands of the end user or the consumer is awesome.
Yeah.
Well, Stefan, thank you so much for joining us. Really, super appreciative of your time. I think, given that we're 13 minutes over, we do need to wrap up. Is there anything you'd like to say before we end?
Well, thanks for the opportunity. Glad to be here. I will probably join the next week's IOH events.
Please do. And I hope that we have many more chats about the Firehose. Okay, everyone. Well, with that, we are out of time. Thank you to everyone who's joined us today. We're very excited to have passed the 1-year milestone, and even more excited for the next year in this incredible community. Don't forget to claim your POAP. You have a few minutes to do so. We've extended the mint deadline. And just to close off, I'd just like to thank some of our most active contributors over the past year. So thank you to Ford, Adam, Jim, Cohen, Derek, Payne, Juan, Oliver, Ottavio, Leo, Vince, Hope, Vincent, Colson, Alexi, Sam, Konstantin, Slim Chance, Steak Machine, and Kai. And I hope we have many more contributors over the year. Thanks again, everyone, and have a good week. Bye.
Bye.
And thank you, Chris.
Bye, guys.
Bye.
Thanks, Chris.
See you guys. See you guys.